Integration, area under a curve. Type 1, area enclosed with respect to the x-axis and the curve. So in these cases where we're looking to get the area under the curve, what we're looking at is the area enclosed under the curve between the given limits a and b and also the x-axis. So in order to find the area under the curve, we say that the area is equal to the integral of y dx within the limits of b and a, where b is the upper limit and a is the lower limit. So in other words, y is the function, a is the lower limit, and b is the upper limit. Okay, so if we have a look at an example. So here we're given a diagram. So in all these questions we're going to be given images of the functions themselves, whereas in the previous questions we were looking at yesterday with definite integrals, you were only ever given the function. So the graph is representing the function y, where y is the function x squared, but we're only given the function between the points 0 and also 3. And we're asked to find the area of the shaded region, which is basically the area under the curve between the limits of 3 and 0 and enclosed with the x-axis. So basically 3 is our upper limit, so the one further to the right on the x-axis, and then 0 is our lower limit. So in other words, it's the values of on the x-axis that are closing off this area. In other words, they're the boundary points. So if we write our area function then, so we're going to say area is equal to the integrand of y dx. So y is x squared. The upper limit is 3 and the lower limit is 0. So in other words, if we look up here, we can see this x squared is our y, where y is our function of x squared. Okay, so now all we have to do is integrate and then sub in our limits. So if we integrate x squared, we add 1 to the power and divide by the new power, so it's x cubed over 3. And then our upper limit is 3 and our lower limit is 0. So we now just simply sub in our limits. And it's always upper limit minus lower limit. So 3 cubed is 27, and 27 divided by 3 is 9. And obviously 0 cubed is 0, and 0 divided by 3 is 0. So that leaves me with an answer of 9. But because I'm specifically looking at my answer being area this time as opposed to yesterday, then we need to put in 9 square units. So again, if we don't include that, that would be an issue. So in the second example here, we're given the function y, where y is equal to 12 over x squared. And we're asked to find the area enclosed by the limits 2 and k. So it's the area under the curve between the limits of 2 and k with respect to the x-axis. So in other words, the x-axis, the curve, and the limits 2 and k are all enclosing off the shaded region. Now what we're told in this question is that we have to find the value of k, the upper limit, given that the shaded area is 4 square units. So this time we actually know what the area is, we just don't know what the upper limit is. So k is the upper limit, 2 is the lower limit, and we know the area is 4. So that means that the area with respect to the x-axis is going to be y, which is 12 over x squared dx, with an upper limit of k and a lower limit of 2. But that area is equal to 4. And we can't integrate 12 over x squared as it stands. So it's not a log function because the denominator is not linear, it's x squared. So that means I must write 12 over x squared as 12 times 1 over x squared. In other words, 12x to the power of minus 2. So if I add 1 to the power when I'm integrating here, well, that's going to give me 12x to the power of minus 1, divide by the new power, and then my upper limit is k and my lower limit is 2. So now all I have to do is sub in my upper and my lower limit. So before I do that, I'm just going to tidy up 12x to the minus 1 over minus 1. So that's going to be rewritten as minus 12 x to the power of minus 1. Well, if I put brackets around that, that can be written as 1 over x. So in other words, that's minus 12 over x. So now subbing in my upper limit, I have minus 12 over k, brackets, minus 12 over 2. So upper limit always goes in first, lower limit goes in second. And then that's minus 12 over k, minus 6 is going to become plus 6. And therefore, that's going to be 12 over k is equal to 6 minus 4, which is 2. So I'm going to multiply both sides across by k. That gives me 12 is equal to 2k, and therefore k must equal 6. Okay, so you're going to go to page 408 in your books, and you're going to do question 11, 12, 13, and 14. So type 2, y-axis. So in these questions here, what we're looking at is a function, limits, and then the area enclosed off because of the y-axis. So you can see all this blue area is shaded because we have the upper limit b and the lower limit a and the y-axis all sealing off the curve, giving this shaded region. So in order for us to find the area enclosed by the y-axis and the limits, our upper limit is b, our lower limit is y, but this time what we're going to be doing is x with respect to y. Okay, so for example, so we're asked to find the area enclosed by the y-axis, the curve y equals root x, and the line y equals 3. So if I look at this function here, we can see that it's cutting the x-axis at 0, and therefore if I shade in the area enclosed by the line y equals 3 and the curve with respect to the x-axis, I get all of this green area here. Now the problem is, obviously, if I want to find the area, then I know the area is the upper limit, which is going to be 3, the lower limit, which is going to be 0, and I have to get x because I'm integrating with respect to dy. Now I can't put in x at the moment because, let me do my rough work over here, I have y is equal to root x. So to get x on its own, I'm going to need to square both sides, which gives me y squared is equal to x. So that means that I'm going to be putting in here y squared because I'm integrating with respect to y when it is the area enclosed by the y-axis, the curve, and the limits. So now I'm integrating with respect to y, so that means I treat y squared the same as I would x squared dx. So that means I add 1 to the power, which becomes y cubed, divide by that new power, which is 3, and my upper limit is 3 and my lower limit is 0. So a bit like the last example we had a few minutes ago, we have 3 cubed over 3 minus 0 cubed over 0, which gives me 27 divided by 3, which is 9 square units. So always making sure you're getting x on its own before you integrate, because all of these functions will always be given as y equals. So that's the big thing to note. So you're going to go to page 409 in your book, and you're getting question 15 and question 16. So you might have a bit of free time today, so it shouldn't really take you the full double to get all of those questions done today. Okay,